Good morning everyone, welcome to the EduSite Network. Today we are going to discuss operations research, its meaning and applications. For this we have with us in the studio our subject expert Dr. Subhash Kakkar. He is a PVC in a reputed university and we can also refer to him as a management guru. He has a PhD, MBA, BE in mechanical from University of Delhi. Additionally, he holds a Six Sigma Master Black Belt and with expertise in SAP, R3 and he's also a PP consultant. So we are very privileged to have such a qualified personality here and we welcome you, sir. Thank you for being here.
Thank you, Urvashi, and welcome viewers. Today we are starting a series of lectures on the subject operations research. Today we shall be discussing its meaning and its applications, and in my subsequent lectures we shall be covering different topics of operations research and we shall be discussing technical aspects of operations research. What is operations research and its meaning? Operations research, we can also call it management science. Nowadays we call it management science and decision science also. Is a scientific approach to decision making that seeks to best design and operate a system, usually under conditions requiring the allocation of scarce resources. This is an elaborate definition of operations research. The meaning is clear. The organizations have scarce resources. We want to put them to the optimum use. To put them to the optimum use, we should have some tools. By using those tools, we should be able to have the effective use of these resources. And at the same time, we may have a goal to maximize some output, to maximize some variable. In certain cases, we may like to minimize a particular variable. If both things are not possible, we may like to optimize that particular variable. But how to do it? And this is the subject, operations research, which comes to our rescue to give an answer to our query, an answer to our problem. And now we'll discuss what is the meaning of system, which has been covered in the definition of operations research. A system is an organization of interdependent components that work together to accomplish the goal of the system. System comprises of different interdependent components. They cannot be considered as standalone components. They are considered working together. And then we have a system which is comprising of these different components. And when we discuss operations research, its definition, and now is OR is emerged. But what is OR? OR is a short form of operations research. We call it operations research, we call it also operational research. We call it management science, we call it decision science. They mean the same one thing, which is the use of some principle to get to our goal, which is maybe maximization, minimization or optimization of our results. What do I mean by operations? The activities carried out in an organization related to attaining its goals and objectives. Organizations are there, they have vision, mission, target, objectives which are to be achieved. They make business strategy, they make business policy. To utilize these variables, to utilize these factors so that their goals are achieved with the minimum efforts and the results are maximized. That is the main aim of an organization. I'll repeat, the activities carried out in the organization related to attaining its goals and objectives. And this is the part of any organization. Organization's basic structure is, basic requirement is to achieve certain goal, which may be in the form of objective, which may be in the form of target, maybe it is in the form of a vision statement of the organization or written in its mission statement. We have discussed operations, we have discussed organization. Now we will discuss the meaning of research. What do I mean by research? The process of observation and testing characterized by the scientific method. The steps of the process include observing the situation and formulating a problem statement, constructing a mathematical model, hypothesizing that the model represents the important aspects of the situation, and validating the model through experimentation. This is a wide and broad and elaborate definition of research. We have a statement, we have a problem in front of us. Rather, we will assume there is a problem in the organization, and the topmost person or the top management vaguely know the problem, and there is a dilemma in the top management about this problem. They are also narrating the problem in their own way, but the people who are going to solve the problem, they will understand this problem, they will state the problem in their own language, and then they will change the statement of the problem to suit the mathematical model. It means they will try to state the problem in mathematical language, and then they will use some mathematical principle to get back to the solution to the problem. For example, director in an institute, maybe you can consider a management institute, finds that early in the morning students are roaming about here and there and they are not attending the classes. His problem is totally indiscipline in the college. He calls a meeting of the head of the departments and discusses his concern about this problem, total indiscipline in the organization. But the fellow who is to solve this problem, he finds what is happening in the college early in the morning. People, students are roaming here and there. He finds that today buses didn't come on time. Okay? On one side, the top management considers it's a total indiscipline. But the fellow who is going to solve the problem, he finds that buses didn't come on time. So the problem is now shifted to the transport department. And the transport department goes deep into the problem and he finds that a new contract was issued for transportation. And he didn't know the timings, at what time the different buses are to report. So the problem is not of indiscipline, the problem lies somewhere else. So the research fellow, who is going to solve the problem, he will state this problem in a different way. Top management consider this problem in a different way, and the final solution which we are going to implement to solve this problem will not be of indiscipline, it will be of something else. So one is to analyze the problem, analyze the statement of the problem, and then finally give a shape in his own language which he is going to solve with his own efforts. So this is the meaning of research, which is the part of operations research. Now we'll define, we'll understand the meaning of organization also. Under organization, the meaning is the society in which the problem arises. The area in which the problem arises is nothing but the organization itself. So, society in which the problem arises or for which the solution is important is called organization. The organization may be a corporation, a branch of government, it can be a branch office, or it can be a department within a firm, a group of employees, or perhaps even a household or individual personality. And this comprises an organization. So, organization which holds the problem and which is finding the solution to that problem is called the organization. We have understood this statement. It can be an individual, it can be a group of people, it can be one department or collection of few departments, or organization itself, or the company itself having 2-3 units all over India or all over the world. So, this is called the organization. Now, we have understood the meaning of operations research, separately operations, separately research, and the meaning of system and the meaning of organization also. Who is a decision maker? An individual or group in the organization capable of proposing and implementing necessary actions, and these actions will lead to the solution of the problem, and this person is called the decision maker. Decision maker can be the topmost person in the company, head of the department, or the individual who is facing the problem. He is the decision maker because this problem belongs to one individual, and one individual is responsible for making any decision. If topmost management is required to take the decision, then the decision maker is topmost management in the organization. The fellow who takes the decision is called the decision maker. Why we are discussing all these definitions? Because finally, when we have a solution to the problem, we will have to get the approval of the person where the problem belongs. So, once again we will discuss what is OR, what is MS. Broadly, we have understood the meaning of operations research and management science. Operations research, again also known as management science, is a collection of techniques. It is nothing but collection of different techniques based on mathematics and other scientific approaches that find solution to your problem. Here, one thing is to be understood: our solutions will lie on the principles of mathematics or scientific principles or scientific theory or scientific concepts. And for achieving that, we shall be stating our problem in a mathematical language. Again, an example can be given and can be understood. There are, say, maybe 10-15 students in the class, and we want to know how much money they are carrying. Each student is in his uniform, is wearing trousers having two pockets, left pocket and the right pocket, and the shirt which has only one pocket. Total, each student has 3 pockets, and these 3 pockets can be used for carrying money. So, left pocket of the trouser or left pocket of the pants, right pocket of the pants, and pocket of the shirt. These 3 pockets can be named as A, B, C. A is the left pocket of the pant, B is the right pocket of the pant, C is the pocket of the shirt. So, each student will be called and he will be asked to identify or asked to disclose what money he is carrying in his left pocket, right pocket and shirt pocket. So, left pocket, if some money is there, maybe 5 rupees. So, A will be equal to 5. Right pocket, if he is carrying 50 rupees, so P will be 50, and C, if he is not carrying anything in his shirt pocket, so C will be 0. Total money carried by the student will be A plus B plus C. A we have said 5, B we have said 50, C we have said 0. So, total will be 55, and the formula mathematical principle we have used is only addition, principle of addition, A plus B plus C. This was a very simple example how we can know the money carried by different students. There are 15 students, and in each case we will be carrying out this process. A plus B plus C will be knowing A, we will be knowing B, we will be knowing, and then we can total it up and we can know that the entire class at this stage has this much amount available in their pockets. So, but we shall be using some advanced principles of mathematics to solve different problems. This was a problem to know the funds carried out by the students attending this class. So, this was the method, okay, and we shall be using a advanced principles of mathematics, and in certain cases we shall be using advanced principles of science also, and in some cases we shall be using deterministic models, and in some cases we shall be using probabilistic models. Deterministic models where exact values are there, okay, there is no variation in that value, but the probabilistic models will have a range of values, okay, depending upon the probability we shall be using a particular value, depending upon the different probability we shall be using another value. So, we shall be having solutions to our problem which could be deterministic and that can be probabilistic also. So, this was the meaning of operations research. There are certain other definitions. Why we are discussing all these definitions? Because at this stage I want that the viewers must be clear about this subject thoroughly. There should not be any confusion at the later stage to know the definition, to know the meaning of this particular subject, that we shall be discussing applications also, so that we should know the importance of studying this particular subject. Other definitions, some more definitions we have to discuss. OR, simply OR, we can say operations research. OR deals with systematic and scientific research on the operations of a system. So, this is being given by McCloskey. This definition say that systematic and scientific approach is to be carried out while solving our problem. So, our statement, our method should not be vague methods, okay. They should have a meaning, and some scientific approach should be attached to our solutions to the problem. Operations research is the application of scientific methods. Time and again I am repeating, these are scientific methods, these are based on mathematical principles. So, we have to bear in mind that only scientific and mathematical approach to the problem will solve and will give us its solution through operations research. OR is the application of scientific methods, techniques and tools to problems involving the operations of a system so as to provide those in control of the system with optimum solutions to the problem. This was given by Churchman, Akoff and Arnoff. Again, repeatedly this has been pointed out that first is systematic approach, next is scientific approach. No things going haywire. Only scientific and mathematical approach to the problem will give us the solution. Whether we are looking for maximization, whether we are looking for minimization, or whether we are looking for optimization. Third definition on this slide is OR is a scientific approach to problem solving for executive management, and this approach is for topmost management. Any sort of problem can be solved by using operations research. Only thing we have to do, we have to narrate our problem in a mathematical language, in a scientific language, and then make use of scientific principles, make use of mathematical principles, and get to the solution of the problem. Of course, we will discuss the procedure which is going to be adopted for finding the solution and implementing the solution. And then jokingly we can say that OR is, operations research is the art of giving bad answers to problems to which worst answers are sought otherwise. Meaning is clear. There is a little difference between solutions which are given by operations research than given by otherwise without using operations research. Again we have some definitions, some more definitions of operations research. Again we are repeating them so that viewers get a complete picture of this particular subject. OR Society of UK defines, there is a society in UK, its name is OR Society of UK, and this society defines operations research as operational research is the application of the methods of science to complex problems arising in the direction and management of large systems of men, machines, materials and money in industry, business, government and defense. This is an elaborate definition of OR, and we will try to explain its meaning, its parts wise. First is science to complex problems. This is talking about complex problems. Why complex problems? Because small problems we can solve otherwise, but the complex problems where lot of resources are required, where lot of variables are present, so we cannot solve the problem manually. We shall be using OR techniques to solve those problems, and that's why we call this is a solution to the complex problems. Then systems, we are not talking about small systems, we are talking about large systems. Again, these large systems, we cannot solve the problems manually. Some principles, some scientific method is required to solve the problem. So one, complex problems, then complex problems of the large systems. And these systems comprising of men, machines, materials, and they may belong to the industry, they may belong to the business, they may belong to the government and non-government institutes also, and they may belong to defense also. So they may belong to educational sector, they may belong to finance sector, they may belong to any sector. Okay? Complex problems, large systems and variables are also large. Then OR comes to the rescue to these kind of problems and gives us the optimum solution. The distinctive approach is to develop a scientific model of the system, incorporating measurements of factors such as chance and risk. I said there are deterministic models, there are probabilistic models. Risk involved with the solution, again we have to study that part of the solution also, with which to compare the outcome of alternative decisions, strategies and controls. OR will give you maybe 3-4 solutions to the same problem, and 3-4 alternatives are to be discussed with respect to risk involved, with respect to probability of solution involved. So we can pick one of them to suit our requirement. The purpose is to help the management determine its policies and actions scientifically. Our main aim is to give fullest satisfaction to the top management, with respect to the solution to the problem, whether it is risk management or whether it is completing a project on time. So, OR will give us the solution to these kind of problems. Different alternative solutions will be there, and the risk involved with those solutions will also be given, and the management has an option to select any suitable method as a solution to the problem. Another definition, earlier definition was given by UK Association, and this particular definition which we are going to discuss is given by Society of USA, OR Society of USA. Operations research is concerned with scientifically deciding how to best design and operate man-machine system, usually under conditions requiring the allocation of scarce resources. This particular definition is talking about, at the beginning itself, this is a scientific approach, and then this is required to design and operate what? Combo of man and machine, and then he is talking about the scarce resources. So, here we are to use scientific approach to design and operate the system which is comprising of men and machine, and this men and machine are utilizing scarce resources. Scarce resources can be funds, can be power, and can be manpower also, maybe land. These scarce resources, their optimal use will give us the maximize results and minimize wastages. So, another definition which is given by OR Society of USA. So, by now I think I have made my viewers clear about the definition of operations research. Now, there are synonyms of OR also. We just call it management science. We also call it operations research and operational research also, and operational analysis also, and sometimes simply we call it OR. So, all these terms mean one and the same thing. Management science, operations research, operational research, or simply OR is the use of mathematical models, statistics and algorithms to aid in decision making process to reach the best possible solution to our problem. And then at the same time, it is most often used to analyze complex real world problems, and I am talking about real problems, and these are not hypothetical cases. We will have a real problem, we will use OR techniques and find a solution to that problem, and typically with the goal of improving or optimizing the performance of the organization. It is one form of applied mathematics. So, in short, we can use, or we can tell, or we can say, we can mean that OR is nothing but applied mathematics. It is applied mathematics, application of mathematical principles for solving the problem. World War II, British military leaders asked scientists and engineers to analyze several military problems. They were supposed to deploy radar, they were supposed to deploy missiles, they were supposed to transport their equipment and manpower from one station to another station, and all these things were to be done in a record minimum possible time. Another problem, management of convoy, bombing, anti-submarine and mining operations. So, which were not possible for a human being to do manually. The result was called military operations research, later operations research. So, in World War II, World War II, when army operations, military operations were to be carried out on a large scale, which were not possible for human beings to handle manually, scientists and engineers were employed to give solution to these problems. And these solutions were in the form of mathematical solutions. And then they started calling it as military operations research, and finally this was called as operations research. This is the origin of the subject operations research. When the army wanted to launch any missile in a shortest possible time, what are the activities involved, and whether one activity is successful or that is failure. So, what next action is to be taken? If it is a success, what action is to be taken? If it is a failure, what action is to be taken? So, there were probabilities attached to these actions, and at that time only scientists and engineers came to the rescue, and they devised a method which was called military operations research, and then the name changed to operations research, and this is the beginning of the subject operations research or management science. The term operations research was coined during World War II. Leaders asked scientists and engineers to analyze several military problems. The scientific approach to decision making requires the use of one or more mathematical models. A mathematical model is a mathematical representation of the actual situation that may be used to make better decisions or clarify the situation. So, mathematical models, mathematical equations are easily understood by engineers, easily understood by scientists, and these mathematical equations explain the entire problem. And when some mathematical tool is used, we get a solution to this problem, and that solution when implemented gives us the best possible results. Now, what is then management science? Again operations research. I am again and again emphasizing on the meaning and definition of operations research. The use of mathematical models in providing guidelines to managers. So, solution is in the form of guidelines for making effective decisions within the state of the current information. Now, he is talking about the state of the current information. If the information is correct, we will get the correct result. If information is wrong, we will not get the correct answer to our problem. So, whatever data are input to the problem, if they are correct, we will get the correct solution. So, it is like this: garbage in, garbage out. If information is in the form of a garbage, we will get the garbage result. So, if it is in the form of a approved data, then we get the approved result. The use of scientific method to the management of organizations. Other similar terms: decision science, systems analysis, operational research, systems of dynamics, operational analysis, engineering systems and systems engineering, and more. And even industrial engineering is also part of operations research. Industrial engineering is also using mathematical principles, mathematical theories, mathematical concepts to find out the solution to the problem. And then now voices from the past. Those people who are not mathematicians, even those people who do not know statistics, they also give a statement which is directly reflecting on the use of mathematical principles. Waste neither time nor money, but make the best use of both. Somebody is telling to make a best use of time and money. This was given by Benjamin Franklin. He was not a scientist, but he gave a statement meaning something towards scientific use of tools and principles so that effective use of time and money is possible. Obviously, the highest type of efficiency is that which can utilize existing material to the best advantage. Now, he is talking about something like best possible use of existing material, and this was given by Jawaharlal Nehru only. So, our leaders were also talking about optimum use of resources so that they get the maximum results. Somewhere in their discussion or in their statement, they were indicating the use of scientific methods or mathematical methods. Then again, it is more probable that the average man could, with no injury to his health, increase his efficiency 50%. Somebody is now asking for a 50% increase in efficiency without spoiling the health, without spoiling the fitness, and without any injury. This was given by Walter Scott. So, all these leaders are also aiming at getting maximum results from the efforts, and they were prompting to use some scientific method or some mathematical models so that their goals and their aims are achieved. Now, we have mathematical optimization in nearly every field. You talk of any field and the use of OR is there. Let us name few. Finance. In finance, OR is used. Financial derivatives, options, and portfolio management. In all these fields, finance and OR is used. Marketing. We want to see the maximum and effective use of marketing mix, and the solution is given by operations research. Nowadays, e-business is common and used by everyone. It's very familiar word nowadays. And e-business also uses the concept of operations research. Telecommunication, which is again use of current affairs. In games also, operations research is used. People make their strategies based on operations research techniques. Operations management, another subject which is slightly different from operations research. How to manage the operations of manufacturing units, how to manage the operations of service industry, OR comes to our rescue. Production planning. In the company, we have to plan our production. Production planning in the organization, in manufacturing, aggregate production planning, master production schedule, production planning and control, then based on pond drainage system, GIT just in time, maybe based on MRP, material requirement planning, and maybe based on TOC, theory of constraints, debottlenecking. In all these operations, OR is there to help the management to take the best possible decisions. SCM, another use for operations research. What is SCM? Supply chain management. And systems design. Designing a system, OR is the technique which is used. Look for it, look for anything, and OR is there to help you. You will see opportunities for its use. OR can be used anywhere and any field. If you go to healthcare, OR is used. If you want to decide which surgery will be performed by which surgeon, which doctor, so assigning the surgery part to the doctors, OR helps us. So OR is used in all the functional areas, in all the fields, what we see or what we think of. Now we will just discuss the qualities of an OR modeler. Who is making the model of the problem? So what qualities one should have? We have written that mathematics, economics and computer sciences background. A modeler must have mathematical background. He must have studied economics, and he should be knowing computer science also, because nowadays things are possible using computer software. The problems are so complex that these cannot be solved manually, and we want to use computer software. So one should have a knowledge of computer science also, along with mathematical knowledge and some knowledge of economics. Then he should have ability to listen. Why this ability is required? Because people are having problem. People are narrating the problem to him. Unless he listens carefully to the problem, he will not understand the problem thoroughly and in depth. And then again, if the problem is not understood in depth, solution is not possible. Then curiosity about how the world works. He should be curious to know how the things are moving and how the problem is occurring from the operations in the organization. He should be curious to know the operations, he should be curious to know the details of the problem, and then he should be curious to know the people who are affected by this problem. And then he should be willing to ask dumb questions and learn from others. Dumb questions means vague questions. He should be ready to ask vague questions so that he gets to know in depth the narration of the problem or the description of the problem. All these qualities are a must in a particular modeler. But again, who is a modeler? The modeler is a person who is converting the statement of the problem given by the top management in the form of mathematical equations. Let's consider one example. XYZ company produces the drug Examine in the huge batches by heating a chemical mixture in a pressurized container. Each time a batch is produced, a different amount of Examine is produced. The amount produced is the process yield measured in kgs or in pounds. This company is interested in understanding the factors that influence the yield of Examine production process. The solution on subsequent slides describe a model building process for this situation. The company is using different factors, and which we are going to see in the next slide, and the company wants to maximize the process yield. What is process yield? It is the output of the process. XYZ company is interested in determining the factors that influence the process yield. This would be referred to as a descriptive model, since it describes the behavior of the actual yield as a function of various factors, because various factors contribute to the yield. These factors are maybe container volume in liters, container pressure, container temperature in degrees centigrade, and These are V, P and T, chemical composition of the processed mixture, and these will finally contribute to what? The process yield, which we want to maximize. And these are factors which are having some influence on the process yield. So, letting A, B and C be the percentage of the mixture made up of chemicals A, B and C, then the company, for example, yield is equal to 300, which is a constant, plus 0.8 times V plus 0.01 times P. P is the pressure, V is the volume of the container, plus 0.06 T. T is the temperature, then 0.001 T into P minus 0.01 T square and minus 0.001 P square plus 11.7 A plus 9.5, 9.4 B plus 16.4 C plus 19 A into B plus 11.4 A into C minus 9.6 B into C. So, why I have chosen to share this example with you to just narrate, because our solution lies in the mathematical formulation of a problem, and we will maximize our yield choosing the percentages of A, B and C, and the quantity of V means volume, pressure and temperature. When these variables are chosen in proper proportion, which is given by our OR solution, we shall be maximizing our yield. To determine the relationship, the yield of the process would have to be measured for many different combinations. Either we should have a different combinations to know that which combination give us the maximum yield. So, knowledge of this equation would enable the company to describe the yield of the production process once volume, pressure, temperature and chemical composition were known. So, here what are the variables? Volume is the variable, pressure is the variable, temperature is the variable, and then composition of the chemicals again is a variable. Composition A, B and C, V, T and P. These are 6 variables which are responsible for giving us the yield. Prescriptive or optimization models. Prescriptive models prescribe only the behavior for any organization that will enable it to best meet its goals. Components of this model include what? Objective function. Objective function, the function which we want, whether it is maximization, minimization or optimization, that is known as objective function. And then there are variables, decision variables, the variables which can be varied, which can have a variable value attached to them, and we want to know the exact quantity, exact proportion of these variables present in our final solution, and then constraints will be there, and these constraints will be in the form of what? Say pressure, we can have a minimum value this much and a maximum value this much. This is a constraint, we can work or operate the process within these 2 limits. Similarly, temperature will also have a maximum and minimum value. Temperature can be operated in these 2 values, and all these composition etc. may have some constraint attached to it. So, we will have an objective function, we will have a constraint also. And this company example seeks to maximize, our objective function is to maximize the yield for the production process. In most models there will be a function we wish to maximize and maybe we wish to minimize. This function is called the model's objective function. To maximize the process yield, we need to find the values of V, P, T, A, B and C that make the yield equation as large as possible. So, the following equation which is on the slide is for the yield, and all the variables with their coefficients are given, and these coefficients if chosen, and they will give you the maximum yield. But still we want to know how did we reach this particular equation. Again, there are methods, there are some mathematical formula, mathematical principles which will be used to come to this conclusion that this particular value for different variables will give us the maximum yield. In many situations, an organization may have more than one objective. Optimization has one objective and can have many constraints. Similarly, we have already discussed the meaning of decision variables and the meaning of constraints, and constraints can be put in the form of maximum values and minimum values. Now, let us assume XYZ company's example, the volume must be between 1 and 5 liters, pressure must be between 200 and 400 units, and similarly temperature must be between 100 and 200 degrees. These are the constraints under which we have to work. Mixture must be made up entirely of A, B and C, and no other chemical be used. For the drug to perform properly, only half the mixture at most can be product A. So, these are the constraints. Within these constraints the company is to work, but how to put these constraints in the form of mathematical equations. So, we said should be between 1 and 5. So, V will be less than equal to 5, or V should be greater than equal to 1, because its volume is between 1 and 5 liters. Say pressure also we put a limit. So, pressure should be less than equal to 4, or pressure should be greater than equal to 200, and we said temperature should be between 100 degrees centigrade and 200 degrees centigrade. How to denote it? T should be less than equal to 200 degree and T should be greater than equal to 100. Similarly, on the composition front, we said A should be greater than equal to 0, B should be greater than equal to 0, and then A plus B plus C should be 1, A should be less than 0.5. So, this is the way we can put our constraints in the form of mathematical equations. So, complete XYZ company's optimization model will be now maximize the function. That function is giving us the yield of the process, maximize Z. So, again we are writing the same equation which is in the form of mathematical equation and subject to some constraint. All these constraints which we have already discussed will be put together. We will have objective function in the form of maximization case and then constraints which are given in the slide, and these will now form the total problem, and some mathematical tool will be used and to get to the maximum yield, and we will get a value of the maximum yield also. So, this is now using optimization software. Software used in this particular case is optimization, and it can be determined that the optimal solution to our problem is V is 5, P is 200, T is 100. So, we had a variation, we had a constraint, maximum values and minimum values. So, now V is now fixed to 5 liters, P pressure is fixed to 200 units, T is again fixed to 100 units. If these three variables are fixed and composition, A should be 29.4%, B should be 0, no B should be used, and C should be 70.6%, and the yield will be 209.384, and no way we can have more than this value. This is the maximization case. Okay. So, this is the way our operation research techniques will be used to get to the final result. There are 7 steps.
Sir, sorry to interrupt you, but we are getting a question if you
Yeah,
allow.
please, yeah.
Yes. Hello. Yes, can we have the question, please?
हेलो
हाँ जी, बोलिए.
Yes.
हेलो
हाँ, बोलिए, क्वेश्चन बोलिए.
ए प्लस बी प्लस सी
आपकी आवाज़ नहीं आ रही है साफ.
थोड़ा क्लियर बोलिए.
चलो पावर ऑफ करता हूँ अभी।
Please reduce the volume of your television. Got disconnected, sir, unfortunately.
Okay.
So we can resume the discussion, and
Yeah,
we
whenever
hope
some
that
query is
he
there,
or she
yeah.
may call back.
Yeah.
Yes.
Okay, now for solving the problem using OR, we have 7-step model building process. First is formulate the problem. Careful observation of the system and discussion of the problems. Define the problem. Specify objectives and determine parts of the organization to be studied to get to know the problem. This is the first step. And then second step, observe the system. Determines the parameters affecting the problem. We have to know the parameters which are going to be part of our solution. And then collect data to estimate values of the parameters. So data collection is a must, and data collection should be done in a perfect and very accurate way. Third step is formulate the mathematical model of the problem. Here model is always an idealized representation of the problem. Exact problem which has been stated by others should be written in a mathematical way. Fourth step, verify the model and use the model for prediction. Does the model have face validity? Does the model produce usable information? Does it answer the appropriate question? Does the model yield results for values of decision variables not used to develop the model? What eventualities might cause a model to become invalid? So here we have to list all these. This is the fourth step. And then fifth, select a suitable alternative. We'll get different alternatives. Depending upon our requirement and suitability, we have to select one of the alternatives. And then present the results in conclusion of the study to the organization. We have to present our results in the form of conclusions to the top management, so that they have the alternatives available, they have the choice, they have the option to select one of them, and implement, evaluate recommendations. Okay, finally, we have now seen different steps which are part of our problem solving process using operation research techniques. And then people have made lot of use of these operation techniques.
Sir, sorry to cut you in, but unfortunately we have come to the close of time, so probably in further lectures we could take up the parts that we may have left unfinished. So again, sir, thank you for being here, and thank you listeners for watching us, and wish you all a very nice day. Thank you again.